Hello, welcome to my class. I am Madam Sania, and today I'm going to take you through regression. So when we started this topic on correlation and regression, we talked about correlation and how to calculate correlation, the different methods. Now we're going to go into regression, and how we're going to calculate it, and how correlation and regression are similar or different. Okay. So first things first, you have to know the meaning. So regression it's concerned with estimating the values of one variable when the values of the other variable is known. So in this case, we are still dealing with two variables. So you have to estimate one variable, say x, when you know the values of y. That is what regression deals with. So this equation y is equals to f of x. F of x is a function. So this means the regression equation of y on x. So if x is the subject, if x is the dependent, x is equals to g of y. This is the regression equation of x. The regression equation of x on y. So here these two variables, you can have the equation of y on x, or you can have the equation of x on y. And they are not similar. It is not the same way when we were doing correlation, you had the correlation between x and y and the correlation between y and x, it was the same. But for regression, it's different. The regression equation of y on x and x on y, they're different. So you have to be very keen. When you're given a question, you have to be keen to see what you're looking at, to see what you're calculating. So we have something that is called the regression line. You will come across this a lot. So the regression line is basically, it is a graphical device used to describe the average relationship between the two variables. So the average relationship between the two variables is represented graphically by a regression line. So you have to calculate this also. So regression equation, regression line, they're normally used interchangeably. So if you have a question and don't calculate the regression line, if you calculate the regression equation, you are calculating the same thing. So we have the regression equation. The method that you're going to use here is the method of least squares. So that is the method, when you're calculating regression, you use the method of least squares. That is what you use when you're calculating regression equation. Remember that. So how do you use the method of least squares? It entails, so for example, I told you can either be told y on x or x on y. So for our case here, you have regression equation of y on x. So your equation, after you do your calculations on f and everything, it should always look like this. Y is equals to a plus b x. So this is an equation of y on x. So where a and b are constants. So a and b are constants, and then y, this is the dependent variable, dependent, and then x, if it is on this side, this is the independent. So when you are doing regression equation of y on x, y is equals to a plus bx. Y is the dependent, a and b are constants that you need to calculate, and then x is the independent variable. So where a is the level of the fitted line, and b, it gives you the slope of the line. So first things first, before you go into it, regression equation, you should know how it's supposed to look like. So you've said y on x looks like y is equals to a plus bx. And then how do you obtain the constants? So the constants a and b, you obtain them by solving these two normal equations. These two, they're called normal equations. So basically you should know them. If it is y on x, it's going to be summation of y is equals to na plus b summation of x. Summation of xy is equals to a summation of x plus b summation of xy, x squared. When you replace these two equations, you're going to solve them simultaneously. So you have two simultaneous equations. When you solve these two equations, you get what a is and what b is. Okay? So that is regression of y on x. So when it comes to regression equation of x on y, the equation is supposed to look like this. X is equals to a plus by. Now our x here is the dependent, and then our y here is the independent. Okay, so the same case, A and B are constants that you need to find. How do you find A and B? You have to solve these two normal equations. Take note, these two normal equations, this one looks like summation of x is equals to NA plus B summation of y. The other one is summation of xy equals to A summation of y plus B summation of y squared. These normal equations, they are not the same. So when you're doing y on x and when you're doing x on y, the equation itself is not the same and the normal equations, they are not the same. So you should take note and know when to use this and know when to use the other one. Okay? So you have an example here. So you've been given a data set. So the data set, you've been given this data on this side. Okay? And then you're told, calculate regression equation. Calculate the regression equation of y of x on y. X on y and y on x. So you've been told calculate regression equation of x on y and y on x. So you're going to end up with two equations. First you should do for x on y and then you come and do for y on x. So when you're doing equation of x on y, you ask yourself, how is my final equation supposed to look like? Your final equation is supposed to look like x is equals to a plus by. That is how your equation is supposed to look like. You ask yourself, how do I get a and b? You've said you get a and b by solving these two normal equations simultaneously, which is summation of x is equals to na plus b summation of y, summation of xy is equals to a summation of y plus b summation of y squared. So you have this. You don't know what summation of x is, you don't know what your n is, you don't know what your summation of y is, you don't know what your summation of xy, you don't know your summation of y, and you also don't know your summation of y squared. So in this case, you have to find. How do you find it? You go back to your data. First things first, equation here to the first one, it wants summation of x. Summation of x, you come to x. It basically means you add the values of x. When you add these values of x, you get 15. Your summation of x is 15. Okay? N is the number of observations. How many observations do we have here? 1, 2, 3, 4, 5. So our n is 5. Summation of y. You go to your values of y, you add these values of y to give you summation of y, which is 25. So we already have our first equation. Summation of x is 15, our n is 5, the a is the constant, so it remains, plus summation of y is 25b. Okay, so that is the first equation. The second equation, we need summation of xy. So that means you first have to multiply x and y. So you multiply here. Now this is what you're calculating, x and y. You take x times y. 1 times 2 is 2. 2 times 5 is 10. 3 times 3, 9. 4 times 8, 32. 5 times 7, 35. After getting x, y, remember you want summation. So you need to add these values. When you add these values, you get 88. Okay? Summation of y, we already calculated it to be 25. What else do we need? Summation of y squared. So we go to your y, you have your y, but you don't have y squared. So you're supposed to do y squared. So when you do y squared, 2 squared is 4, 5 squared is 25, 3 squared is 9, 8 squared is 64, 7 squared is 49. And then what do you need? You need the summation. So when you add these values of y squared, you get 151. Sawa? So you come and replace these values here in your formula. Summation of xy, we got it as 88. Our a remains, summation of y was 25a, plus b, summation of y squared is 151. Sawa? So you have plus 151b. Now you have these two. You have these two equations, okay? And the whole essence of doing these two equations is so that you can know what a is, so that you can find a and b. Now we have these two equations. You're going to solve them simultaneously. You're going to solve simultaneous equation. So for this case, I'm going to use the substitution method. I'm going to use the substitution method to solve. Sometimes other people can use the elimination, so it depends with the one you know. But for our case, you can use any. But today we're going to use substitution. You can use elimination, that's fine. But for today you're going to use substitution. Substitution now, when you're solving, you take one of the equations. So for our case, I took the equation 1. This equation, I simplified it. Simplifying it means I divided it by 5 to make it simple. So it became 3 is equals to A plus 5B. So I made A the subject. So A is equals to 3 minus 5B. Okay? Now you're taking this equation and then you substitute it in the second equation. So we took this, we made it the subject, and then we substitute this A in the second equation. So where you have A, you're going to replace with 3 minus 5B. So our second equation now, this one here, 88 is equals to 25. So we have A, we replace it with 3 minus 5B plus 151B. So 88 is equal, now you open the brackets, 25 times 3 is 75, 25 times 5 minus 125B plus 151B. You take like terms on the same side. So this comes this side, becomes negative. 88 minus 75 is equals to 151B minus 125B. 88 minus 75 is 13, is equals to 26B. So you divide by 26, you divide by 26. So your B is going to be a half, which is the same as 0.5. Now you already know what your B is. And you know your equation A is given by 3 minus 5B. So if you replace B in this equation, you already know what your A is. So your A is 0.5 and your B is also 0.5. But you don't stop here. What was our question? We're told to calculate the regression equation of x on y. And we've said our regression equation of x and y should look like this. It should look like x is equals to a plus by. But we already know what our a is and we already know what our b is. So we just replace. So x is equals to 0.5 plus 0.5 y. Okay? So this is the answer for y on x. So you should try for y on x and make sure you get this answer. You should see if you get the same answer. Okay? Yeah. So here, after that, you're going to look like, they're going to look at the b now. The quantity b is the regression coefficient. Now that is something else you should know. Sometimes the question does not even want you to calculate the regression equation. They just tell you find the regression coefficient. They tell you find the regression coefficient. It means you're finding this value b. You're finding what b is. So always remember regression coefficient of x on y or y on x. So if it is x on y, so our bxy is equals to r delta x over delta y. Remember what r is? Correlation. Remember, small letter r is correlation. And if it is y on x, it is r delta y over delta x. Okay? So when you simplify this equation, because you do not want to find the standard deviation, we say the sigma, it shows you the standard deviation. So when you simplify this equation, it's the same as summation xy over summation y squared. But this is for the case of x on y. For the case of y on x, when you simplify this, you get summation of xy over summation of x squared. So when you're told maybe you just find the regression coefficient, this is what you're going to do. Okay? And you get the answer. So properties of a regression coefficient. Properties of b. So when you take bxy times byx and you get the square root, it gives you r. And you said r is the correlation. So when you take this b of y on x and this b of x on y, and this b of y on x, you multiply them and get the square root, you will get the correlation. Okay? The other property is the coefficient of correlation and regression have the same sign. So if maybe you're doing the same question, you've been given the same data set, you've been given find the correlation, maybe got negative 0.8 as your correlation. Your regression also, when you come to calculate it using the method of least squares, you should also get a negative answer. If you get a positive answer, just know that somewhere you've gone wrong. Your correlation and your regression, it's supposed to have the same sign. If they're positive, they're both positive. If it's negative, they're both negative. Sawa? The other property is, when you take the average of the regression coefficient, it should be greater than correlation. So when you have x on y, the b and the y on x, you add them, you divide by 2, it should be greater than your correlation. So if it's not, just know that somewhere you've gone wrong. And then the other one is, regression coefficients are independent of change of origin but not scale. So these are the properties. So we have that. So another thing to note is, you should know the difference between correlation So now that you know what correlation is, you know what regression is and how to calculate them and the properties and all that, you should also know the difference between the two. Just to recap what we've done on regression, remember, when you have a regression, you've been told find the regression equation. You have to be keen. Is it x on y? Is it husband on wives or is it wives on husband? Is it numeracy on qt? Is it qt on numeracy? You have to be very keen because they're not the same. It's not the same as correlation. They will not be the same. So if it is x on y, your equation is supposed to look like this. After getting this equation, you're supposed to find what a is, what b is. How do you find a and b? By solving these two normal equations. How do you solve these two normal equations? You solve them simultaneously. How do you get these values? From your data. From your data. Use your data to get summation of xy. Use your data to get summation of y squared. Use your data to get summation of x squared. And remember, x on y and y on x is different. The normal equation, these ones are for y on x. Summation of y is equals to na plus b summation of x. And summation of xy is equals to a summation of x plus b summation of x squared. So you should be very keen because the two are going to give you two different answers. Okay? So you should be very keen to note if it is x on y or if it is y on x. And then remember to do that example and again you should be able to get that answer. So we've come to the end of correlation and regression. Yes. I hope you've understood. See you in our next.